So thank you. Thank you for having me and for organizing. As Sven just said, I'm going to present Pricing for the Stars, Dynamic Pricing in the Presence of Rating Systems, which is joint work with Christoph and Peter, who are both in attendance, I think. So the motivation for this paper is that rating systems on online platform allow for information transmission between consumers, and I don't think I need to, given the audience, talk much about that, but this is of course incredibly important for demand and for the platform's functioning as such. So we know that roughly 82% of consumers read reviews before shopping online. On Yelp, there's evidence that a one-star rating increase for restaurants increases revenues by between 5 and 10%. And there's multiple other studies that really show very well that demand is strongly affected by what we see in aggregate ratings and individual reviews. A second observation that motivated us to start this project is that the design of rating systems themselves frequently changes. And one change in particular that we found interesting and that we want to speak to is that recently there's a push for ratings, for the aggregate ratings, like the star ratings on Amazon, more prominently displaying or reflecting what the most recent reviews said. So if the product has already been sold for the last 5 years, the aggregate rating will not simply put on an unweighted average of all of the reviews that have ever been written, but instead more prominently count those that were written in, say, the last 60 or 100 days. And this is something we also see on the video game platform Steam, where we separately can see the overall average review on top of what's the average over the last 30 days. And this is something that we ideally want to analyze. How does that interact with one particular way in which sellers can manage their rating, and that is strategic pricing. So in principle, there's of course a great many ways in which sellers who are incentivized to take care of the rating because it affects demand can affect it, for example, by investing in the quality of the product or service that they're offering. It might be illegal means such as fake reviews, but there's in fact one very simple way that is legal and that is used all the time, which is they can strategically adjust the prices to exploit that the information transmission between consumers in the form of reviews is imperfect. And what we want to focus here in terms of imperfection in particular is that we don't necessarily observe all the characteristics of past consumers and their experiences that are entering into the review. So what I mean by that specifically is, suppose that I read a review. If it's written by somebody like Christoph, whose tastes perhaps closely mirror my own, that's great. Because I can read it, I can infer exactly how does his taste match up to mine, and therefore from his experience infer something about the product. But this is not how it works in practice. In practice, I don't know exactly who wrote that particular review, and while the text of the review might give me some information, that's very limited. And on top of that, there's a second fundamental thing that I don't observe, which is what was the price at which the person who left the review purchased the good in the first place. Because that does not necessarily need to be my own. But we know that it enters the review, and therefore this is something that gives the seller leeway to strategically set the price, both to affect the review that is left, but also to select amongst the consumers that are purchasing and therefore leaving reviews in the first place. So the questions we want to ask in this paper is, how does all of this come together? And in particular, how does the design of the rating systems, in particular the sensitivity to recent reviews, affect the pricing incentives of firms? How does that impact on the information transmission and long-run price levels, and therefore consumer welfare, because this is what we should care about. How are the consumers who are purchasing on the platform affected? And to answer these questions, we provide a tractable framework of dynamic pricing in the presence of rating system. We consider a single firm that sells a good of fixed quality to short-lived consumers. And we basically purchase tractability by having consumer inference be based on a heuristic where they treat the game as if it were in a stationary equilibrium already. And I will be much more precise on that later on, the motivation for it and how this stacks up to the literature. But this is basically the assumption we make. What we get out in turn is that we really have a perfect characterization of the price path, of the review path, and then of the long run outcomes. What we do in this model is we capture two empirically documented effects that have also quite a lot of evidence for them, and they're seemingly at first glance opposed. The first effect is that there's a direct price effect, which is if I buy the same good at a higher price, I tend to lower my review. That's just because I get less value for money, and we know that this inclines people to give less favorable reviews, because reviews do not simply reflect quality as such, but also the value that the good provided. So this is perhaps relatively innocuous. What's a bit more subtle but has gathered increasing attention by the literature is that there's also a selection effect. If I increase the price, then all else equal, the kinds of people who are going to buy the good are going to be those that are positively inclined towards the product in the first place. And this selection actually has a positive impact on reviews. So for example, in the context of books, I might be somebody who likes fantasy books. If the price for a fantasy book is high, I'm still going to purchase it because I like it. But somebody like Chris who dislikes them will not. And overall, that might actually lead to a positive effect on the reviews. Now, in our model, we're going to take the strength of the direct price effect as something that is product specific, and then show that this direct price effect dominates the selection effect for standardized product, and the selection effect dominates otherwise. And this lines up very well with the empirical evidence, this interpretation, because what we empirically see is that higher prices are associated with lower reviews for goods like USB sticks. There's a study by Cabral and Lee from 2015, but higher prices lead to higher reviews due to the selection effect in the context of books, which was done by Dynus Segners in a recent working paper. And we also have our own analysis of video games on Steam, where we show that there is a positive relationship, higher prices leading to higher reviews for video games as such, but that this is reversed when we look at casual games, very simple games where value for money matters, where it is in fact lower prices that induce higher review scores. So I'll be just skipping the related literature for time constraints and jump right into the model, what we're doing. So the model features discrete time and a single long-lived seller with discount factor delta. The seller sells a good of privately known fixed quality theta, and we normalize production cost to 0. In each period, there's amassed one of short-lived consumers who are alive just for that period. And they, when they conditional on purchase, enjoy a gross utility that depends on the quality theta, and on top of that, on their idiosyncratic taste omega. So they value quality and taste is distributed for now uniformly 0, 1, just to keep things simple. But we will have later on a lot of extensions that relax some of these stark assumptions in the baseline model. Conditional on purchase, each consumer leaves a review with an identical probability, which is again something we can relax. But this review now reflects not only the gross consumption utility, theta plus omega, but on top of that, it partially internalizes the purchase price, P. And we parameterize this internalization by kappa. And this is something that, as I've said before, we view as a product-specific feature. For very standardized products, kappa is close to 1. We, in our review, report something that is closer to net utility. And that is because these are goods where value for money is what really matters. For less standardized products, this kappa is less than 1, and we care more about the intrinsic value of the product as such, and not so much how much it offers relative to the purchase price. Okay, we have a rating system that is given by an initial attitude towards the product parameterized by some initial rating, psi bar 0. And then the updating of the aggregate rating in each period works as follows. We take last period's rating, weigh it with 1 minus sigma, and add sigma times the average review of the current consumers. So we take the set of all consumers who currently purchase, we take the average review that they leave, and we use that to update the aggregate rating. And of course, we can again extend that to allow for more practical considerations, such as if more people purchase, we update more strongly. But for now, we really just take this average between the average review and weighted average between the average review and the stock rating. And the sigma parameter is exactly what allows us to speak to the different rating system characteristics. If sigma is high, then we put a higher emphasis on more recent review scores, which means the aggregate rating that consumers see more strongly reflects what happened in the last periods. If sigma is low, by contrast, it gets closer and closer to really an unweighted average of all past periods. Okay, so in the stage game, we see the aggregate rating. The firm sets its price, and then the consumers use just that aggregate rating and that price to conduct inference and make their purchase decision, whereafter they leave a review, again, all consumers with the same probability. Now, what I have been silent on so far, outside of the short speech in the introduction, is how exactly do consumers conduct inference, and that is something that I want to get to now. So the idea behind it is as follows. It's really motivated by basically our own shopping experience on Amazon. So when I go on Amazon and I look for a product, I see the aggregate ratings, I might see also some of the individual reviews and read them, but in particular, I do not know, as I've argued before, the tastes of the consumers who purchased in the past and left a review. And I also do not know at which price they purchased. And there's very little, it's very rarely the case that within the review, you actually see a specific price point being mentioned. So what I'm doing when I'm shopping is I take the current price as the best predictor of past prices. I think in the past, consumers faced a similar situation to me and evaluated the product, therefore, based on having purchased as a roughly the same price. But that, of course, will also determine just who purchased. And my hope is ideally that it's people who are somewhat more close to me. So when I'm conducting inference, I look for the pair of the inferred quality mu star and the cutoff taste omega star, such that on aggregate, I exactly match this aggregate rating that is on display. And at the same time, such that the purchase decisions are individually rational, which means that the cutoff type is exactly indifferent between purchasing and not purchasing at that particular quality. So that means consumers treat the game as if it were already in a stationary equilibrium. And we can formalize this in this fashion. So we have two equations which we solve to conduct inference. On the one hand, the review that is left, given that the quality is actually the inferred quality mu star, by the average consumer who purchases, omega E of omega star, and the price exactly matches the aggregate rating on display. And at the same time, the marginal type, this omega star type, is exactly indifferent between purchasing and not purchasing. Now, this renders consumers broadly rational, but this is in line with what other studies have done in the literature that looked at strategic pricing in the presence of rating systems. And basically, it means that consumers ignore some of the information that's contained in the current prices. It means that there is no explicit price signaling, which is very advantageous for tractability. And what we can show is that based on these assumptions, inference is uniquely determined and the resulting demand is well behaved in the sense that a higher rating increases demand, but a higher price will always lower demand. Now, having done that, we can solve this inference problem analytically and then compute the effect of the price on the induced review. Because when we care about the firm which wants to strategically manage its rating, it needs to ask, by changing my price today, what's the impact on the induced reviews that I get in this period and therefore on the rating in the future. And what we can show is that this is decomposed into two effects: the direct price effect, whereby increasing the price, I directly lower reviews, and the selection effect, where by increasing the price, I increase the taste of the cutoff consumer and therefore increase the average reviews. And what we can then show is that the direct price effect dominates if and only if this kappa is large enough, if and only if the direct price effect is strong enough. And the reason is as follows. The direct price effect is very strong when kappa is large. That's clear, because kappa directly parameterizes the direct price effect. But it also changes how we read the current combination of aggregate rating and price. If kappa is high and I see a given rating at a higher price, then I rationalize that not via an adjustment, a strong adjustment in the taste component, in the cutoff component, but instead via a higher quality. Conversely, if kappa is low, I rationalize it more via an adjustment in the taste component, which means demand is more responsive. And not only is the direct price effect low, kappa weak, but also the selection effect strong. So overall, this implies that the relationship between prices and induced reviews depends on kappa. If kappa is high, the direct price effect is strong, selection effect is weak, and a firm who strategically manages its ratings via prices will charge low prices to induce high reviews. Conversely, if kappa is low, then I want to increase my price to exploit the selection effect and get a higher rating in the future. So we can then set up a dynamic programming approach. We can write our value today as a function of only the current aggregate rating, and we maximize our value by choosing the price that maximizes the combination of flow profits, price times quantity in this period, plus the discounted future value from the induced aggregate rating that we're going to get next period. And the rating updates according to the process I've said before, 1 minus sigma times the current rating plus sigma times the induced average review. We can guess and verify, use the guess and verify approach, just like in PhD macro 1, to obtain actually a closed form solution to this problem. And we do that by first replacing the price as the control variable with the induced rating next period, because there's a one-to-one mapping between the two, then guess that the value function is quadratic, which implies a linear policy function, and equate coefficients to actually get closed form solutions for optimal pricing and value function, and then take the limit to get the long run outcomes. And this leads me directly to our main results. The first one is that all firms, such that at least some consumers should purchase, meaning there's at least some consumers for which the taste is large enough that they overall enjoy a positive utility, we converge to a stationary equilibrium in which the rating system is effective, meaning that all consumers learn the quality in the long run. The firm remains active, and every period charges the same price and induces an average review that coincides with the aggregate rate. So we converge to a stationary equilibrium in which naturally then the inference is going to be correct forever. Now this is despite the heuristic, and we can show that the speed of convergence is determined directly by this parameter sigma. So if sigma is high, we converge more quickly than if sigma is low. If we favor in the aggregate rating more recent reviews, we have faster convergence. What is perhaps more interesting is what are now the resulting impacts on the long run profits, prices, and consumer surplus. And there we need to distinguish between the seller side. The seller always benefits from a rating system that's more sensitive to new reviews. The reason is that if I have a very sensitive rating system, then it's cheaper for the seller to obtain any particular target rating it moves to from any given current rating. And that means seller profits are always increasing in the sensitivity because it is just simply put cheaper. I need to distort my price away from the myopically optimal price less to obtain the same result. For consumers, this is different. So for consumers, it depends on whether the seller manages the rating by charging higher or lower prices. If the sensitivity of the rating system goes up, it will always mean that the seller will engage more in the strategic price setting to dynamically manage the ratings. So if we have a strong direct price effect, that means the seller induces high ratings via low prices, which means when the sensitivity goes up, we actually exert downward pressure and consumer surplus increases. By contrast, if the direct price effect is weak, the seller manages the rating via the selection effect. That means we have upward pricing pressure when the sensitivity increases, and consumers are detrimentally affected because price goes up and consumer surplus goes down. So if we then look at the recent changes by rating systems on platforms such as Amazon and Steam, they definitely benefit the firms, but they may harm the consumers, in particular for products where the selection effect is strong, because we have upward pricing pressure and a decrease in consumer surplus. Now we have a lot of extensions and robustness in the paper that I just want to mention very briefly. We look at what are the actual platform incentives when the platform maximizes a weighted sum of profits and consumer surplus. And we show, just as you might expect from the last slide, that it prefers a sensitive rating system either when it's beneficial for all parties or when the weight on consumers is sufficiently low. And then we can also address a bunch of modifications, such as incorporating the number of reviews into the updating rule, distribution over the reviewing agents, because we know empirically that it tends to be more bimodal. Consumers with extreme experiences tend to rate, consumers with less extreme experiences tend to rate less. We can talk about different distributions of horizontal preferences, competition between different sellers, stochastic ratings, and so on and so on. So let me wrap up and then refer you to the paper if you are interested. We provide a framework of strategic pricing in the presence of rating systems, which is tractable because consumers use a heuristic to conduct inference where they treat the game as if it were in a stationary equilibrium. This means there is joint inference about the quality and the characteristics of previously purchasing consumers, conditional on observing the current aggregate rating and price. We have these two effects, the direct price effect and the selection effect, that are going in opposite directions. And we show that the price effect outweighs the selection effect if and only if the direct price effect itself is large, which in turn, though, also parameterizes the strength of the selection effect. And then we can look at the long-run properties, show that learning occurs despite the heuristic, that firms are always beneficiaries of more sensitive rating systems more sensitive to recent reviews, but that consumers may be adversely affected provided that a higher sensitivity induces the firm to engage in more strategic ratings management via prices, and that the selection effect is what allows them to induce high reviews, in which case we have upward pricing pressure and a decrease in consumer surplus. Thank you, and that would be it from my side.